Hello students, today we will learn that what is regeneration in Rankine cycle, why regeneration is done, what is the scope of regeneration in Rankine cycle, what is the job of Rankine cycle. Here the job of the boiler is to prepare the steam. It takes liquid water in at point 4 and ejected superheated steam from up to the point 1. See here, in this video, we are going to learn about the regeneration and reheat cycles. First one is about the regeneration. The regeneration cycle, regenerative cycle. This cycle is used in steam turbines to improve its performance. The dry saturated steam from the boiler enters the steam turbine at high temperature and then expands isentropically to a low temperature. In the previous classes, I have showed you about the Rankine cycle which we are using in thermal power plant, that how it works based on the 4 components. Here in this slide, that the dry saturated steam from the boiler, that after some work steps in the boiler, the steam, super saturated steam or dry saturated steam will come from boilers and enters to the steam turbine with a high temperature and then expands isentropically to a low temperature. The condensate from the condenser is pumped back and recirculated around the steam turbine. See that the main difference in Rankine cycle as well as in regenerative cycle is that in Rankine cycle, from boiler, the superheated steam or the dry-saturated steam with high temperature and high pressure enters into the turbine, and then in the turbine the steam which has been entered with high temperature and high pressure has been expanded, and after expanding in the turbine gives some work and leaves into the condenser with a low pressure, as well as the temperature will also be decreases, and from the condenser it directly enters into the pump, and through pump the heat enters again into the boiler and the recirculation has been done here. But coming to here in the regenerative or regeneration cycle, here the condensate from the condenser is pumped back and circulated around the steam turbine. Means from the condenser, what is the steam we are having here is again pumped to the turbine. Means we are not directly entering this condensated steam into the pump. Means here some condensation has been takes place, that the steam the heat is going to be rejected here, and it will converts into water in the condenser. But coming to the regenerative or regeneration cycle, what is the steam which has came into the condenser is again sent to the turbine, and then the condensate is thus heated before entering into the boiler. Thus the condensate, what is here the steam is condensed, is thus heated before entering into the boiler, that the condensate means which has been converted into water is heated before it is going to be enter into the boiler. Such a system is known as regenerative heating, as the steam is used to heat the steam itself. That here the regenerative means nothing but of pumping back from the condenser to the turbine and circulating around the steam turbine, and thus heated steam or the heated water uh, before entering into the boiler is nothing but of a regenerative heating, as the steam is used to heat the steam itself. This is nothing but of a regenerative cycle. Coming to the diagram, see what is happening in the Rankine cycle. Here in the regenerative cycle means, see, we are feeding water. Feed water is feeded into the boiler. Here the feeded water from the boiler has been converted into supersaturated stream or dry saturated stream. The supersaturated stream or the dry saturated stream will enters into the turbine at point 1, and in the turbine the steam with high pressure and high temperature, with the superheated steam which has been entered here into the turbine will expanded isentropically in the turbine, and after expanding in the turbine it leaves to the condenser with low pressure and low temperature into the condenser. In the condenser, some condensation has been takes place, means the heat is going to be rejected here, and the steam which has been entered into the turbine is going to be cooled here, and by using of this pump, see here, the using of this pump is entered into the flow water heater. See, before before it is expanded in the turbine, some of the steam has been exhausted out. See here, the steam which has been entered from the boiler to the turbine, superheated steam which has been entered from boiler to the turbine, the total superheated steam is not converted or is not expanded. Before expanding, some of the steam has been extracted and giving to the flow water heater. Here the remaining superheated steam has been expanded and entered into the condenser, and by using of this pump it enters into the flow water heater, and the from the condenser, what is the water we are getting here, after heat rejection and after converting the steam into water, the remaining steam which is coming out from the condenser has been pumped to the boiler through the pump and by using of flow water heater. When the water which has been, means the water which is coming out from the condenser is fully cooled, as we are using some external source, as we are giving some external water to cool up the steam and for converting the steam into water. The cooled water is entered into the pump, and the cooled water is pumped to the flow water heater, and from the turbine again the steam which has been exhausted is entered into the flow water heater, and then here the cooled water is again reheated here, and then it enters into the pump too, and by using of this pump the feed water is feeded into the boiler. This is the recirculation of the Rankine cycle, which is used for these reheating regenerative cycle. This is the diagram of regenerative cycle. And coming to here, see here in the regeneration, this is the other diagram which I am showing here, that here into the mass 1 kg of steam is entered of water, 1 kg of water, 1 kg of steam is entered into the boiler, and this 1 kg, see here we can observe that, assume 1 kg of steam is expanded in the turbine, means here in the diagram we are sending 1 kg of steam to the boiler, and this 1 kg of steam after dry saturated or super saturated is entered into the turbine. See here, after studying this, before complete amount of steam is expanded, some amount of steam mkg is extracted and utilized for heating the feed water. See what I have told you, this in the turbine some of the steam has been exhausted, and the remaining steam is entered into the condenser, mkg of steam. See what here, before complete amount of steam expanded in the turbine, before before complete amount of steam is expanded, some amount of steam mkg of steam is extracted and utilized for heating the feed water here, which is coming out from the condenser to the through pump. See what is happening here, that before completing of steam expanded, the steam which has been entered from the boiler is entered into the turbine, and here the steam is not fully expanded. Before the amount of steam is expanded, some amount of steam, means some amount of means nothing but of mkg of amount, mkg of steam is extracted and utilized for heating the feed water. For heating this feed water, some of the steam has been extracted, and the remaining steam, means the remaining steam 1 minus mkg of steam has been entered into the condenser, and here the heat, see here we can observe here that, so remaining amount of steam 1 mkg, 1 minus mkg is completely expanded in the turbine and condensing in condenser as shown in figure. In the regenerator, mkg of high temperature steam and 1 minus mkg of condensate are passing. Here that 1 minus mkg of steam is entering into the condenser, and here heat transfer from steam to condensed feed water takes place. So this process increases the enthalpy of feed water, means here the process which enters 1 minus mkg of steam is or the feed water is going to be entered into the pump 1. See here that this process increases, the process which we are studying here will increases the enthalpy of feed water. Thus the heat supplied to boiler will be reduced, means the heat which we are supplying here to the boiler will be reduced as the enthalpy has been increased to the feed water. This is about the regeneration cycle, which what is happening here, that from boiler it enters into the turbine. In turbine, some of the steam has been extracted for heating the feed water coming from the condenser, and the remaining steam, means 1 minus mkg of condenser steam is expanded and has been sent into the condenser. After condensation, means heat rejection, some the amount which has been converted into water, feed water, is again passed to the pump to the heat exchanger or regenerator or feed water, and the extracted steam from the turbine is given to the this feed water heater for heating the feed water which is coming out from the condenser, and 1 kg of steam is again sent to the pump 2, and from pump 2 again we are sending these to the boiler. This is about the regeneration which has been done here. See, regeneration means simply we are giving here heading that the topic is about regeneration and reheat. See, coming to here, regeneration means heating the feed water by steam taken from the turbine. Simply that what I have explained you from the diagram, that the superheated steam which has been entered from the boiler into the turbine, before expanding all the steam, some of the steam has been exhausted for heating the feed water by steam taken from the turbine. That the feed water which is coming out from the condenser to the pump, the from the condenser, by using of this feed water which has been taken from the turbine, has been heated. This is nothing but of a regeneration. The steam is exhausted or built from the turbine at several locations before exhaust and is supplied to regenerated to heat the feed water. See here, we are having an equation that extracting a steam in the turbine before exhaust is also called bleeding. Extracting the steam in the turbine before exhaust means the steam before exhausting into the condenser. This is known as bleeding. Extracting the steam in the turbine before exhaust is called bleeding. Heat balance equation. When we are going to balance the equation here, that how we are going to balance the equation means heat lost by bleeded system. Bleeded system is nothing but of extracting the steam in the turbine before exhaust into the condenser. That heat lost by bleeded steam is equal to heat gained by feed water. That what is the heat lost by bleeded steam is nothing but of m into H2 minus HF2 is equal to heat gained. What is the heat gain here in the diagram which we can observe here is nothing but of 1 minus m. 1 minus m. See here, 1 minus m into HF2 minus HF3. We have calculated, we are multiplying here m into H2 minus m into HF2 is equal to HF2 minus HF3 minus m into HF2 minus of minus plus m into HF3. Therefore, m value is equal to HF2 minus HF3 by H2 minus HF3. See, coming to here, see, work done in the turbine per kg of feed water before bleed. Before bleed means before extracting or before entering into the condenser. Work done in the turbine per kg of feed water before bleed is nothing but of H1 minus H2 means isentropically in the turbine, isentropical expansion has been takes place means nothing but of H1 minus H2 kilojoule per kg. And coming to here, work done in the turbine per kg of feed water after bleed of steam. Before bleed, we are having H1 minus H2. And after bleed of steam, we are having 1 minus m into H2 minus H3 means nothing but of where we are doing this condensation from point 2 to 3. We are writing the difference of enthalpy from point 2 to point 3. Therefore, the total work done is equal to H1 minus H2 plus 1 minus m into H2 minus H3. Therefore, total heat supplied for kg of feed water is equal to H1 minus H3, HF3. Therefore, total heat supplied per kg of feed water for kg of feed water, when we are feeding water to the boiler, per kg of feed water we are supplying here. Therefore, total heat supplied per kg of feed water, for kg of feed water we are supplying heat here is equal to H1 minus HF3. Therefore, thermal efficiency of the cycle including the bleeding efficiency, how we are going to calculate the thermal efficiency means nothing but of efficiency is equal to total work done by heat supplied. Here thermal efficiency, what is the total work done we are having here is nothing but of H1 minus H2 plus 1 minus m into H2 minus H3 by H1 minus HF3. See here that thermal efficiency is equal to H1 minus H2 plus 1 minus m into H2 minus H3 by H1 minus HF2. This is about the regeneration. This is about the regeneration or regenerative cycle. Means we are regenerating the cycle here. Regenerating means nothing but of what I have said you. Regeneration means nothing but of heating the feed water by steam taken from the turbine is nothing but of regeneration here. Coming to the next topic, we are having here the next topic is about reheating. What is happening here? Reheating means we are heating again. Reheating means two times. First we are heating, once we are heating, and again we are going to heat here. See here, this is the reheater which we are heating again. See, you all knows that what is happening here, that from the boiler, from the pump we are feeding the feed water to the boiler. As in the boiler, as it has been converted the feed water into superheated steam, the superheated steam is entered into the high pressure turbine. Here in the high pressure turbine some work has been takes place, and it again reheats here. In the reheater, it passes into the reheater. When comparing with the Rankine cycle, that after entering into the turbine, it enters into the directly it enters into the condenser. But coming to the reheating cycle, after the superheated stream from the boiler enters into the high pressure turbine, it is going to be expanded, and the remaining steam is entered into the reheater. After reheating, it is then expanded into the low pressure turbine. From low pressure turbine, it enters into the condenser, and from the condenser it again passes to the pump, and from the pump it again passes to the boiler. This is about the reheating cycle. Here we can observe the TS diagram of reheating cycle, that what is happening here in from 6 to 1. 6 to 1 is nothing but of the feed water which entered into the boiler, turbine work takes place, and it enters into the high pressure boiler, and after that 2 to 3 process we can observe here. 2 to 3 process reheating takes place. 2 to 3 process reheating takes place, and from 3 to 4 it enters into the low pressure turbine. Means 3 to 4 process it enters into the low pressure turbine. 1 to 2 is the high pressure turbine, 3 to 4 is the low pressure turbine, and 4 to 5 is the condenser. It enters into the condenser. 4 to 5 process it enters into the condenser, and 5 to 6 process it enters into the pump, and 5 to 6 process it enters into the pump, and the feed water which remains in the condenser is going to be feed by the pump to the boiler, and again the reheating cycle or the Rankine cycle is going to be complete here in the temperature versus entropy diagram. Here, if the dryness fraction of the system leaving the turbine is less than 0.85, then corrosion and erosion of turbine blades occur. If the dryness fraction of system leaving the turbine is less than 0.85, that if the dryness fraction in the turbine is less than 0.85, then corrosion and erosion of turbine blades occurs. Means corrosion will take place in the turbine. To avoid this situation, reheating is used here. To avoiding the corrosion and erosion in the Rankine cycle, the reheating is takes place here. By observing the figures above, in the reheat cycle, the expansion of steam takes place in one or more turbines. See that in the reheat cycle, the expansion means the expansion is going to be done in high pressure turbine as well as in low pressure turbine. See, steam is expanded in the high pressure turbine first, then it is reheated. The reheated steam is again expanded in the low pressure turbine. What I have said you in the diagram itself, that steam is expanded in the high pressure turbine, then it enters into the low pressure turbine. It is again expanded there, and reheat cycle gives small increase in cycle efficiency. By using of this reheat cycle, the cycle efficiency is going to be increased. It increases the network output. Reheating means heating the steam between turbine stages, means between HP, high pressure stage, and low pressure stage. That P1 is equal to boiler pressure, P2 is equal to P3 is equal to reheat pressure. What I have shown you in the TS diagram, that P4 is equal to condenser pressure, T1 is equal to boiler temperature, T3 is equal to reheat temperature. See here, in the Moeller diagram, we can observe the reheat cycle. If T3 is not given, then we can assume T3 is equal to T1. We can assume that this T3 is equal to T1 as both are at superheated stages. See here, what is happening here, that in the process, when we can observe here that, see, 6 to 1 process is a boiler process. So here we can observe here 6 to 1 is the boiler process, and from the boiler it enters into the high pressure turbine, and it enters into the reheater and enters into the low pressure turbine. From low pressure turbine it enters into the sphere, it enters into the condenser, from condenser it enters into the pump, and again the recirculation is going to be done. And we can observe this Moeller diagram by for solving different problems of reheat cycle here. And coming to here, we are having an equation for this, that H1, H2, H3, H4 is nothing but of enthalpies taken from Moeller chart diagram for these Moeller diagram. HS diagram or steam table. H5 is equal to HF for condenser pressure. WT means nothing but of H6 minus H5. Here we are having that H6 minus H5, and Vf is equal to specific volume here. See, we can write here this pump pressure is nothing but of Vf into P1 minus P2 into 100, as I have said you in the earlier classes how to write the equation of this. And work done of turbine is nothing but of H1 minus H2 plus H3 minus H4, means here the work done is going to be done at 0.1 to 0.2 and 0.3 to 0.4. Hence we are writing here that H1 minus H2 plus H3 minus H4. And work done at pump is nothing but of, where we are doing the pump work means nothing but of H6 minus H5. Hence we are writing here the equation as H6 minus H5. And total net work done is nothing but of work done of turbine minus work done of pump, work done of turbine minus work done of pump. And the total heat supplied is nothing but of, the total heat supplied is nothing but of H1 minus H6 up to, from 1 to 6, what is the heat supplied here, minus H3 minus H2, means here what is happening here, from 1 to 2 some expansion has been takes place, and reheat has been done from 2 to 3 process, means some heat has been supplied here. For that we are taking here H3 minus H2 also. Therefore, net thermal efficiency is nothing but of W net W net by QS means heat supplied. By using of these equations, we are going to solve different problems of these regenerative and reheating cycle problems in the next classes. Today, in this video, we have completed the regeneration and what is mean by regeneration and reheat cycles. In the regeneration cycle, what is happening that regeneration means we are extracting the steam from the turbine and heating the feed water which is coming out from the turbine is nothing but of the regeneration which we have studied here. And coming to the reheat process, that what is the feed superheated steam which is coming from the boiler is entered into two turbines, that in the high pressure turbine as well as into the low pressure turbine. As the superheated steam has been expanded in the high pressure turbine and low pressure turbine, the cycle performance of the cycle efficiency is going to be increased. This is about the regenerative or regeneration and reheat cycles which we have studied in this video. Thank you. If you have any doubts, please contact to this mail ID or please call. Thank you.